Hello my dear friends, myself Ashok D. Bagda from Dr. Subhash Technical Campus, and in today's lecture we are going to discuss about introduction about balancing from the subjects of dynamics of machinery. So let us start. So in this session we are going to discuss about types of forces, need of balancing, static and dynamic balancing, and effect of unbalance in machinery. So before starting, let us see one example. So my dear friends, if our body is not balanced, then we know that we cannot stay on the flooring. Sometimes we may also lay down on the floor or okay. So we know that if our body is not balanced, then we can imagine that what happens. Similarly, my dear friends, every machine must be a balance. So if machine is not balanced, then there is a number of effect. We can say that there is a uneven noise, vibration, sometimes machine maybe fails, and some such kind of problems may be developed in a machine. So my dear friends, we can say that every machine must be a balance. So first of all, let us. So a machine, generally if we consider any machine, my dear friends, if we consider any machine, then a machine having three types of parts. Some parts having rotary motion, that means rotating parts. Some parts having reciprocating motion, that means reciprocating parts, and some parts, out of these some parts having some rotary as well as reciprocating motion. So these parts are known as a floating parts. So every machine, in any machine, there are three types of parts are available: rotary parts, reciprocating parts, and floating parts. So my dear friends, each and every component of machine subject some forces. So first let us understand about static forces. So static forces. So the static forces acting on the machine component are due to the weight of component. In a simple way, we can say that. So my dear friends, static force. So in a simple way, we can say that when the magnitude and direction of the force remain constant at any instant of time, then we can say that our force is static force. If the magnitude and direction of forces acting on machine component is remain constant at any instant of time, then we can say that it is a static force. Suppose there is one table is resting on a flooring. So after, suppose because of this weight of the table, some force acting on the earth. Now after 5 years, if we come again and see that what is the force acting on the earth because of this table, then we can say that this force having same magnitude and same direction. So we can say that because of some such kind of forces are known as static forces. Now we consider dynamic forces. So dynamic forces, the dynamic or inertia forces are due to the acceleration of various components of the machine. The acceleration may be due to the change in magnitude or may be due to the change in direction of velocity. The resultant inertia force or a dynamic force change in magnitude or direction both or all through. In the most of cases, only change in the direction. My dear friends, the dynamic forces, in a simple way we can say the dynamic forces means when the magnitude and direction, both or either magnitude or a direction will change at given instant of time, then we can say that forces is known as the dynamic forces. So the loading on the road, suppose if we consider a bike is if we riding a bike on a rough road, then our bike will consist some dynamic forces. Now let us understand need of balancing. So my dear friends, if our machine is not balanced, then we can say that there are some vibration, uneven noise, sometimes our machine parts may be failed. So let us consider why balancing is required. So in comparison with static forces, the dynamic forces is very large in magnitude. So let us consider an example, a 1-ton rotor of a steam turbine running at 3000 rpm. The distance of center of gravity of rotor from the axis of rotation is 2 mm. Due to the imperfect machining, inaccurate pitch of blade, non-homogeneity of material, etc., then the resultant dynamic force will be a centrifugal force, because here this is the shaft, this is the rotor, and the CG of this rotor is displaced from the neutral axis of shaft. So we know that some centrifugal force may be developed in this direction. So centrifugal force Fc is equal to m r into omega square. If we put the value, then we obtain 197.39 kilonewton. My dear friends, the dynamic force of such high order produce a hammering action. Now my dear friends, if we consider static forces, then there is a 1-ton rotor. So 1 ton means 1000 kg. 1000 kg into 10, around 10 we multiply with gravitational force 10. So 1000 into 10, then means 10,000 Newton. So 10,000 Newton means 10 kilonewton. So static force is, the value of the static forces in this rotor is 10 kilonewton, whereas the value of dynamic forces is 197, that means around 200 kilonewton. So we can say that the dynamic force is 20 times more than the static forces. So if the dynamic force of such a higher order produces a hammering action, set of vibrations, and has a tendency to relieve the machine from the foundation, it is realized that no foundation will normally be able to withstand forces of such high magnitude and frequency, and that's why balancing is required. The balancing, now we can say that what is balancing? So balancing is the process of correcting or eliminating either partially or completely the effect due to the resultant inertia forces and couple acting on machine parts or a component. Thus in a simple way we can say that what is balancing? So in a balancing, our aim is to reduce unbalanced forces in the machine parts. Okay, to reduce or to eliminate unbalanced forces. Thus, the purpose of balancing is to avoid vibration of machines by balancing the resultant inertia forces and couple. The balancing is highly essential, especially in high-speed applications such as electrical motor, generator, turbine, pumps, aircraft, and machine tool, etc. So my dear friends, balancing is always required in a high-speed application. So we know that there are the various high-speed applications, machines are available. So we always balance the high-speed machines. Now let us understand about static balancing. The system is said to be statically balanced if the center of mass of CG of the system of masses lies on the axis of rotation. My dear friends, we have seen this example. So in this case, the CG of rotor is not on the axis of rotation of shaft, and because of that, this rotor is having some unbalanced forces. So when the center of gravity of the body or a system lies on the axis of rotation, then we can say that our system is statically balanced. In another way, we can say that for the system to be statically balanced, the resultant of all dynamic forces acting on the system during the rotation must be 0. So in a simple way, we can say that if summation of all dynamic forces acting on the system is 0, then our system is said to be a static balance. Now another one is a dynamic balancing. It is also known as a complete balancing. The system is said to be a dynamically balanced if satisfied following two conditions. First, the resultant of all dynamic forces acting on the system during the rotation must be 0. That means summation of all dynamic forces acting on the system is 0. If this condition is satisfied, then system is said to be a statically balanced. Now, my dear friends, sometimes the unbalanced forces acting on the machine in a different plane, then because of the direction of unbalanced forces in a different plane, some couple may be also produced in such kind of machine. Then if we balance the couple, then we can say that our system is dynamically balanced. So the resultant couple due to the all dynamic forces acting on the system during the rotation about any plane must be 0. That means another condition, couple due to the dynamic forces acting on the system is 0. That means if all the couple acting on the system, summation of all couple acting on the system is 0, then we can say that our system is dynamically balanced. That means if two condition is satisfied, summation of all dynamic forces acting on the system is 0 and summation of all couple acting on the system is 0, then our system is said to be a dynamically balanced. If only one condition is satisfied, that summation of dynamic forces acting on the system is 0, then we can say that static balancing. Now, effect of unbalance. My dear friends, we know that there is a various effect of unbalanced forces, unbalance in machinery. So we know that if our bike, we can say that if our bike or automobile, if we consider, if our bike is unbalanced, then there is a uneven noise in a machine may be created. So if any machinery having uneven noise, then we can say that a machine having some unbalance. Second one is a vibration. We know that if our system is unbalanced, our machine is unbalanced, then some vibration may be occur in a machinery. Sometimes we consider looseness in a assembly parts. My dear friends, we know that in our bike, after some period of time, we have to tighten nut and bolts, various nut and bolts in bikes because of vibration, because of unbalanced forces. And another effect is a fatigue failure of component. So our component of machinery may be failed because of the unbalanced forces. So my dear friends, I hope you understand about the balancing and why we need balancing and what are the effect of balancing. Thank you.